D is the point on OB such that the ratio of O to D in the ratio of D to B is 2 to 3. Well, as O to D, therefore, is the 2 parts, I can label that as 2. And D to B, that's our 3 parts. I can label this as being the 3. In total, 2 add 3 gives us 5 parts. Hence, O to D, that's 2/5. And D to B, that's 3/5 of the vector OB. I now need to find the vector OB. Well, O to B, I'm starting at O and I want to get to B. Well, I can go up O to A, which in this case I know is just positive A. And I have to come along A to B, which now in this case is the vector just plus B. Hence, my vector O to B is just simply A plus B. As I know the vector now, O to B is A plus B. Therefore, the vector O to D is 2/5 of O to B. Hence, this is 2/5 of the vector A plus B. And D to B was 3/5. So therefore, D to B as a vector is going to be 3/5 of A plus B. E is the point on BC such that the ratio of B to E in the ratio of E to C is 1 to 4. Well, B to E, therefore that's the 1 part. And E to C, this is the 4 parts. Adding up the total number of parts. Well, 1 add 4 gives us 5 parts. Hence, B's 1/5. And EC, that's 4/5 of BC. I now need to find the vector BC. Well, BC means I'm starting at B and I'll get down to C. Well, one way is I can go from B to A. As I'm going in the opposite direction to the arrow, therefore I must put a minus in front of the vector. If A to B in this direction is positive B, therefore B to A in the opposite direction I'll put minus. Therefore it will be negative B. Now I'm at A and I'm going to go from A to O. As I'm going in the opposite direction to the vector, I must put a minus in front of it. So O to A is positive A. As I'm going in the opposite direction, I'll put a minus in front of the vector. Hence, I can have minus A. Now I'm at O, and I want to get from O to C. I'm going with the vector, I'm going in the right direction. So just copy the vector, in this case, plus 3B. Simplifying, i.e. collecting like terms on the right-hand side. I know that 3B subtract B, they're like terms, as they both end in single B. Well, 3B subtract 1B will give us 2B. And I've still got minus A. Now I have the vector BC. I know B to E is 1/5 of BC. So my vector B to E will be 1/5 of 2B minus A. And E to C will be 4/5 of my vector BC, which is 4/5 of 2B minus A. As I want to work out the vector DE in terms of A and B, well, DE means I'm starting at D, and when I get to the point E, I want that vector here. Well, therefore, D to E, one way is I can go up D to B, which I know in this case is 3/5 of, in brackets, A plus B. Now I'm at B, I'm now going to come down B to E, which I know in this case is plus 1/5 of, in brackets, 2B minus A. Expanding out each of my single brackets, whatever's directly outside, I multiply by each term directly inside my single bracket. Well, 3/5 times A will give us 3/5 of A, and 3/5 times B will give us 3/5 of B. Once again, expanding my single bracket, I multiply the term directly outside my single bracket by each term directly inside. Well, positive 1/5 times 2B will give us positive 2/5 of B, and positive 1/5 times negative A will give us negative 1/5 of A. Simplifying, i.e. collecting like terms, on the right-hand side. Here I can see I've got 3/5 of A, subtract 1/5 of A. They're like terms, as they both end in letter A. Well, 3/5 take away 1/5 will give us 2/5 of A. Collecting my B terms here, I've got 3/5 of B plus 2/5 of B. Well, they're like terms, they both end in single B. Well, 3/5 add 2/5 will be 5/5, and 5/5 is 1. Hence, I've just got one lot of B.